Natalie, and I'm an engineering student at The Ohio State University, and I'm here to tell you about the Laser Measuring Device 4-H Engineering Challenge. In my lab, we do research with DNA origami, which is building tiny nanoscale structures out of strands of DNA. We've built things like boxes, spring scales, and gears, and someday they'll be used in cancer research. But they're so small we can't even see them with our own eyes. I have my three structures separated into these boxes, and they're mixed in a solution with water. But I forgot to label them, and now I can't tell them apart. What I do know is that each of the three DNA origami structures have a different length. So if there's a way that I can measure the structures in each of these mystery boxes, I'll be able to tell them apart. But how do I measure such a small structure? The answer is with a laser. Your DNA origami structure will be printed out and attached to a cardboard easel made out of a cereal box. Your goal is to measure the distance from one end of the structure to the other while standing 3 feet away by using the laser pointer and 2 small mirrors. In real DNA origami, we attach fluorescent particles to each end of the structure, and when they're hit with a light, they glow. But for our challenge, we'll be using mirrors instead of fluorescent particles. It's very important to position your mirrors at exact 45-degree angles to ensure that the light is reflected properly. The next stage is to build a launch device to hold the laser and a catching device to stop the reflected light. My device doesn't work that well, so I need to go back and make some new drawings to improve my first design. Once the light is reflected back, you can measure the distance from the laser pointer to the reflected light to successfully identify the DNA origami structure. When your device works well from 3 feet away, try 10 feet away, or the other side of the room. Does it still work well, or are there more improvements that need to be made? Good luck, engineers. I know you can do it.